Let's look at this strange right-hand rule. Wrapping your brain around this explains, believe it or not, how electric motors work. We talked about that. It explains how electric generators work. It will explain how we create power out of nothing, not out of nothing, out of kinetic energy. And it will explain how railguns work. There's a lot of deep understanding when you wrap your brain around the right-hand rules. So, maybe for the last time in the course, good old Anne. So it wants the direction of the net force. Okay. What's the direction of the force, quiet please, in number 1? Your hint is it's a trick question. No force, because we said that for magnetic lines to apply a force, the moving charge or the current has to cut through or across the lines. So here, no force. Number 2, is it a positive charge or a negative charge moving? Positive. So my right-hand rule will work. If it was a negative charge, I'd point my thumb in the opposite direction. It's going to be thumb up the page, fingers to the right. I think the net force is going to be into the page. And you could either say into the page, or I'm going to abbreviate and I'm going to use this. Right? Number 3, current is positive charges. Moving to the right, magnetic field up the page. You know what? Here, the force is out of the page. Number 4, the negative velocity is into the paper. I don't do negative charges, Madison. That means the positive velocity is out of the paper. So my thumb's going to come out of the page. Magnetic field to your left. My palm is pointing down the page. The force is going to be that way, down the page. Number 5. Magnetic field out of the paper, charge moving to the right. So let's see. Charge to the right, magnetic field out of the page. Oh, you know what? I think if I just bend my arm like this, my thumb is pointing to the right behind me, the magnetic field is pointing out of the page, down the page. You know what? I think, is the force down the page? Yes? Ooh, a little trick here at an angle. Oh, no. This is not going to be components. I'll be able to handle this. Current is going up and right. Magnetic field into the page. You know what? The force is going to be in that direction there. It's going to get pushed up and left. Current out of the paper towards me. Magnetic field to the right. Up the page relative to my board. A negative moving up and left, that's the same as a positive moving down and right. So I'm going to point my thumb that way. Magnetic field out of the paper. I got to do a bit of a bend, but I think the force is going to be down and left. Is that correct? Yes? Then I turn the page over. So 1 mark for all of those. All right. Determine the orientation, labeling which end is north and which end is south. So first thing I do, this is the solenoid rule. I label the current. I hold the solenoid. I imagine holding the solenoid in my hand. I can hold it this way or this way. Sorry for those of you at YouTube. I curl my fingers of my right hand in the direction of the current. I think the current is coming over the top towards us. Yes? Not going away from us over the top. Going this way. So my thumb tells me that's the North Pole. That's the South Pole. The magnetic field line outside would go like this. They didn't ask you to do that. I'm just pointing this out. Inside, the magnetic field is pointing to the right. Really, your thumb also tells you the direction of the magnetic field inside the solenoid. That's really what it's doing. I think the next one is going to be opposite because I think now the current is going over the top away from us. So I'll change colors, but I'm pretty sure that's the North Pole and that's the South Pole. 1 mark. Here I'm going to have to figure it out. Let's see. Current goes this way, this way, this way, this way. You know what? It's the same as the first example. I'm pretty sure that's... No. That's south and that's north. Is that correct? Double check. Yes. So 1 mark for each of those. Okay. Determine the direction of the force on the wire for each of the following. So here's... I better draw in the magnetic field lines. Which way do magnetic field lines always point, from what to what? So I'll draw in a couple. So it looks like the wire, the current is coming out of the page towards me. That's what that dot means. Magnetic field is, I'm pointing the wrong way. That way. And Keegan, if you did that, you could smack Nick upside the face. I'd be fine with that. But I think the wire is going to feel a force up the page, yes? F is, up the page. Wire is into the page, magnetic field to the right. Oh, this wire is going to feel a force down the page. Ooh. First, I'm going to have to figure out the direction of the magnetic field. So here's my solenoid. It looks like the current goes this way. So if I hold the solenoid in my hand, I have to hold it like this to curl my fingers in the direction of the current. So that's north, that's south. So the magnetic field line points from what to what? North to south outside the solenoid. Which way is the magnetic field pointing right where this wire is? Down the page. So I have current coming out of the page, magnetic field down the page. Ugh. I think this wire is going to feel a force to the right. That way. Last one, or last two. Sketch the path of the charged particle. Assume the particle is a proton. What are those dots supposed to hint at? Which way is that external magnetic field? I think out of the page. So let's do out of the page. Ugh, that's awkward. Oh, no, do it this way, Mr. Dewitt. That works. So pointing to the right, magnetic field out of the page. I think this proton is going to get deflected, correct me if I'm wrong, like that. Like, is that right, or am I wrong? Right. People nodding. And boom, boom, oh, this one's going to get deflected like that, in a circle. You can give yourself a lovely score, please, out of 16.